Hi, everyone. My name is Tom McCoy, and today we're going to have a talk about storage with built-in cybersecurity and how you can protect data with built-in cybersecurity. Today's talk is designed to be generic. It's not supposed to be a pitch about Cygent, even though I'm from Cygent, and you'll see slides that have Cygent in the background. The reason for that primarily is because a lot of the innovation, a lot of the intellectual property for this type of technology was invented by Cygent and is available through them. But there's more and more companies that are starting to have the same concept. You're seeing more of these capabilities built into storage from big name manufacturers around the world. So let's go ahead and get started. I'm going to go ahead and share my screen here, and you guys can follow along on the presentation. So I'll start off with just a quick introduction to myself and then Cygent, and then we'll go into general architecture of storage that has built-in cybersecurity. We'll then get into some of the pain points and the challenges of data theft and data breach attacks and things like that happen that we're trying to address here. We'll get into capabilities, and then with any available time at the end, I'll demonstrate some of these capabilities so that you can see them real time, which I think is when it really all comes together. So my personal background, I've been in technology for over 30 years now. I originally started working with storage back in the mid-90s with the first manufacturer of storage for removable media. That was a 32K SRAM PCMCA card that had a little battery in it that if you accidentally bumped the battery off or out, you lost all of your data on your SRAM card. So we've obviously evolved and come a long way since then. And so really excited about doing this now. So I've been at Cygent for over 2 years, responsible for alliances. I work a lot with our public sector customers as well. And Cygent's background, prior to Cygent, for me, I was at Dell. I was there for 7 years, and I was in the commercial PC business. The last 5 years at Dell, I was responsible for the portfolio solutions for endpoint security. So managing everything from biosecurity, some of the supply chain security solutions that we had, as well as data at rest, data in motion security, and third-party partnerships that we had with folks like Cylance and RSA and VMware and folks like that. So Cygent's background is we've been around at Cygent for 4 years. We come out of another company that's one of the leading organizations in the world for advanced data recovery, forensics, and destruction, working with the US government and other commercial enterprises and countries around the world to be able to address different issues in relationship to how do you make sure the data is truly destroyed off of media, how do you recover data off of media, and a lot of forensics work. So this idea of coming up with a way to protect data from attacks on endpoints and on storage devices, and endpoints could be a server, it could be eventually a phone or mobile device, an IoT device, a laptop, removable media, external media, et cetera, any kind of a device. This idea came out of work that this company that a lot of us at Cygent came out of that have been doing advanced data recovery for over 30 years now. And what they did is they said, listen, you know what, we know all these mechanisms to recover data and to bypass encryption and things like that. How can we come up with a storage solution that others will not be able to bypass and do all the things that we know how to do to prevent data exfiltration? And they came up with some of these ideas. They put them into a prototype, got them to some folks in the community, and one thing led to another, and Cygent was formed 4 years ago with some backing from Incutel, who's a VC firm that is seriously invested into solutions like this. So that's Cygent's background. Let's talk right away about what we want to really get into, which is what does it mean to have storage with built-in cybersecurity? What does that mean at all? So fundamentally, we would suggest that the starting point is to have a storage device that has built-in hardware encryption. We, on our SSDs at least, use TCG Opal 2.0. It could be TCG Rupee. It could be AES-256 encryption from a different type of methodology. If you use something like TCG Opal, there's a lot of additional capabilities inside the spec that aren't used, in many cases these days that you can do some additional things with. So I would say fundamentally it starts with going with a full disk or hardware encryption drive like an SED. Then you have your standard firmware code. And then I believe that the first most fundamental step is to augment and modify the firmware of that SED to be able to provide other capabilities that allow you to provide additional layers of security. And we're going to walk you through those here in the next half an hour or so. The next, thing you could do with the storage would be to add a microprocessor to it with built-in cybersecurity code that allows the drive itself to be able to monitor for different kinds of attacks and to look at the data going in and out of the drive, look at the firmware, et cetera. So you can get an extra layer of protection by embedding a microprocessor that's discrete and having additional code running inside that microprocessor. And then if you want to continue to go down the path, you would add other capabilities, other hardware capabilities, such as an accelerometer or a disconnect detection circuit, or maybe additional capacitors so you can remain power after you remove the device and take action on it after the drive is no longer connected to a power source inside of a PC server, external case, et cetera. A lot of capabilities you can already, without any kind of an endpoint agent, any kind of an OS agent, already realize just with that architecture alone, because you have power, you have a processor, you're doing different things. So there's a lot that can already be solved just and done with that combination. If you want to go further, though, you can add an endpoint agent and a Linux agent, a Windows agent, a Mac agent, whatever it is, and have that agent be able to do additional capabilities and additional functions that you'll see here in a little bit to augment what can be done just on the drive itself. And then last but not least, you could optionally have a cloud-based or an on-prem management console that could pull data off of the agent and off of the drive, as well as take action on the system remotely, monitor it, reporting it, do incident response, things of that nature. So that's the architecture that we see when we talk about this topic. And then the thing that I like the most about this technology and the idea of embedding cybersecurity into the storage is really what you see on the far right of the screen. And it's when most of the security solutions that are out there for endpoint security are really in that application layer. There's this whole philosophy of rings where applications are at ring 3, and then you kind of go down to -2, -3, et cetera. And really it's about privilege. It's around how much rights you have and root of trust and all these things. And really the fundamental concept is that the lower you are in the rings, the more capability you have to be able to bypass the security in the rings above it. And so if you're able to get into the OS at the kernel level, you're able to get into the hypervisor, or below that into the BIOS, or into the device itself, maybe the motherboard, and put another chip on there that you don't realize is on the motherboard, or a trace or something, you have an awful lot of ability to then side channel over into the storage and steal data and maybe never even find out. And if you build your cybersecurity protections into the storage itself, you're able to be adjacent to all of those. And it doesn't matter where you are in that stack, you're in your own world, your own enclave, if you will, within the storage itself, to be able to defend against all those different attacks, the ones that you may never know. You'll probably never know if somebody has a physical hardware implant inside of your device. Like, there's no way you would know that. But the storage device itself, by protecting the data in and of itself, can protect against those type of attacks. And then, of course, you can then link the software, the application that's running to the storage, and we'll show you that in a little bit, to be able to connect those together and defend against attacks that are seen in that way as well. So moving on, now let's talk a little bit about what are we trying to do? What are we trying to protect against? And I would say there's 3 different macro level areas, and I'm going to highlight these and then double click into a couple of them with a couple slides. The first one is a direct physical attack. So someone retrieves your laptop. So you lose it, you leave it at the airport, or you leave it in the hotel and somebody gets access to it. All sorts of different scenarios. Maybe it's your removable drive, like one of these that you have your storage in, and you send it to somebody, or you leave it somewhere. How do you protect against that direct physical attack? The second is a remote attack. So we are all concerned about, do I have somebody on my system right now? Is there an adversary inside of the network? Right. So having your protections inside of storage can really help, even with in-use data, and making sure that adversaries can't steal that data. And we'll talk about that in a little bit. And then the last is ensuring that all of the blocks on a drive have completely wiped after a storage erasure attempt. And our company that we come out of has done a lot of research in this area. There's a blog on this topic on SciGen's website if you want to read it. And really what we found by buying drives off of eBay and buying phones and all these different things, we found that most of the drives, most of the storage out there is still leaving important data on the drive, even when the software that's used to erase it reports that all of the data has been wiped on it. It's really not deleting it. And there's a lot of reasons why. Sometimes the software wasn't built properly. Sometimes there's wear leveling. There's a lot of different reasons. And so what we did is we created a simple capability that verifies that all the blocks on a drive have truly wiped after you attempt to do an erasure attempt. So with that in mind, we want to address that. So talking a little bit further about these, unpacking a couple of these real quick. Most people that are trying to protect data on a device from a physical loss are trying to do some kind of a full disk encryption. Maybe it's a software full disk encryption, like your BitLockers, or maybe it's a hardware full disk encryption. And the challenge is that a lot of these solutions have been bypassed, and it's public information. And pretty much all of them can be bypassed if you have enough time and resources and know how to do it. And the ways to get by them are sometimes as simple as getting a password kit, or of course you can compromise the user's credentials. You can log into their PC and access data. And then there's other ways like reverse engineering firmware, trying to compromise and figure out how the chip that was designed on the external drive with the pin pads on it was developed and coded, and did they make any mistakes in how they designed it? So just finding vulnerabilities in the approaches. And the unfortunate reality is that a lot of the technology that's out there has adversaries and folks that are involved in advanced data recovery have been able to bypass them. And so we need a new, different methodology to be able to address this. The other thing that I think we need to evolve as an industry is to really think about why are we unlocking all of the data and making it all readable as soon as the user does a pre-boot authentication? So right now, all these full disk encryption solutions, especially the hardware ones, you do a pre-boot auth, you log in with a username or a password, or a PIN or a CAC card, and the entire drive is decrypted and all the data is then available at that point. We are moving towards a different approach, a different way where you can actually have portion of the drive be readable for the OS partition, and then the rest of it be a data partition that stays locked and the ranges stay unreadable at the sector level until after you have logged in and you're using special software to be able to unlock those ranges. And when you go in that different approach, it's a significantly more secure way to protect data. So the other is the remote attacks. I mentioned this earlier. I think there's a lot of different ways that adversaries are going about bypassing, current security solutions. One of them, though, that I don't think is addressed much or talked to, and I think you can address with these solutions with hardware with security in them, is basically the challenge of an adversary remotely disabling your endpoint security software. So they go in there and they disable your AV or your privilege escalation monitoring software or your EDR solution. And then they can go do kind of whatever they want to on the system. And so I think there's some ways that we've addressed this, and we'll share them for the community to be able to understand how to resolve this. So let's talk about the solutions themselves. What are the capabilities that we're solving, and how are we solving them? And it starts with the two that are up on the screen. Invisible data is really the fundamental aspect of this. And so we are able to do this with a lot of the existing hardware encryption specs, like your AES-256 or your TCG Opal 2.0. But it really pivots off of that idea of let's not make the entire drive readable as soon as you boot up. Let's have an OS partition. If it's only one drive in the system, let's have an OS partition and then a data partition. And when you have the data that's in this state where it's in an unreadable state at the sector level, that is really the creme de la creme of how you keep data from being accessible by adversaries. A lot of these really advanced methods to go bypass that, even things like what's called chip off, where you take a chip off of the motherboard or the PCB and you try to look at it with microscopes, they still can't see the data when the data is in a a locked state and it's unreadable at the sector level. And so I think that's really a new way to think about things and to be able to incorporate this. And the other part is to come up with new ways to be able to protect the keys that are used to unlock the drive. At Cygent, we've done basically quite a lot around this and have patented a lot of this. But the idea is to be able to have your credentials so that they're not easily retrievable and accessible by an adversary. And we do that by, first of all, it's maximizing the full maximum capacity of the key lengths, which for us is 256 characters. We also go in there and cryptographically derive the password and the key, or the key off of the password based on different data sources. And then we never store the entire key in its entirety in any single location. So that combination of protecting the locked ranges with credentials that are created this way really is a significant advancement in how you can really protect data more securely than ever before. The next is really talking about that idea of your software that can be disabled. And so what we've done at Cygent, at least, is we have a zero trust file access software application that runs on the system that allows you to protect data if you're actively using it. So once you've made the data visible when it was previously an invisible state, now your data is accessible to adversaries while you're actively working on it. And so we created a multi-factor authentication for file access. And what an adversary might do is they might say, okay, well, great, I'm just going to go disable Cygent software and I'll bypass that. So what we did is we created a Keep Alive Heartbeat. And the Keep Alive Heartbeat is a firmware-based heartbeat that is constantly waiting for the Cygent software to ping it. And if it ever doesn't receive the ping within the allotted amount of time, the storage itself at the firmware layer responds by locking down the ranges where the data is. And this is a great way to be able to use the firmware inside of the storage as a protection to make sure that whatever designated software, it could be the Cygent zero trust file access software, it could be your endpoint protection or any of these security solutions, or even just an application that you designate as critical, to make sure that that software is running on the system. And if it ever is disabled, just to make the data inaccessible and invisible. So again, this is our Keep Alive Heartbeat capability, which we think is really fundamental to the story here. Now, in addition to that, there are several other just firmware layer protections that you can incorporate into your storage without adding accelerometers or microprocessors or anything like that. And we've got a few of them listed up on the screen. So one of those is a new patented method that Cygent has developed for verified data destruction, that after you do an erasure, you can pull the drive inside the firmware and look at the state of every single block on the drive and determine whether or not all of the blocks that can be erased in erasure attempt, so excludes firmware blocks, but all the other blocks, whether or not each and every one of those blocks has truly been wiped after an erasure attempt. And this is a great way to be able to verify that whatever attempt, whatever mechanism you thought you implemented to be able to destroy the data was successful. So that's one more. And again, that's at a firmware layer built into the firmware itself. The next one is something we call secure access logs. So I'll set it up with kind of what are we trying to solve for this. There's a few different things you can do with these secure access logs, but the scenario would be that you have an insider and he has access to your system. He's a trusted user and he has access to critical relevant data. And we all know of the big name insiders that have been out there. So you can just imagine those names in your head. And the challenge with those situations is that those adversaries were inside the network, they were on a trusted PC, and they rebooted their computer from a different USB stick with a different operating system. So like a Linux or a Tails or one of these operating systems. And they were able to extract the files that they wanted to steal from the organization they were at by putting them onto that USB stick. And the challenge is that as IT security teams, we don't have any idea what a person is doing when they've restarted their computer and they're booted off of a different USB stick. So this idea of secure access logs is designed originally and initially to address that challenge. So what we do is that we store the data access logs from the drive itself into a secure area in the drive that even if you do an erasure attempt of the drive, does not delete those logs. And the end user, first of all, doesn't know that it's even doing that. And even if they did, there's no way for them to wipe their tracks to delete those logs. And even, after a fact, if an adversary does all their stuff and they delete all of whatever they did on Windows, or they even format the drive, those logs are still there. And what that allows you to do is be able to go in there after the fact and to be able to figure out what blocks were touched on the drive. And then you can also then map those with the file tables and be able to determine what files were in each block at that time, to be able to then run a report for incident response and detect and to know whether or not that user, what they took, and also, as important, what they didn't take. So that's what secure access logs are. And then you can do other things on that, as I'll get into on the next slide as well. But that's what that is. The last is dual mode. It's a really interesting capability. This is based on using the namespaces part of the storage and the specs. And what this allows you to do is essentially have two operating systems on the same drive. And I've been in this for a while, as I said, and it seems like we've been trying to figure this out for years, right? How do we have a PC that reliably has two completely separate operating systems? And this is a way to do that. And it's pretty phenomenal. This kind of, imagine a 2 terabyte drive, just for easy math, and there's two 1 terabyte drives on it, and they're separated at the namespace level. And what the value of the namespace level is that you can make them mutually exclusive. And so if you were to go into the BIOS on the system that I'm running right now, by the way, which has a 2 terabyte drive, and look at the BIOS, it would show you just 1 terabyte of storage. And so an adversary is on the system and he's looking at the drive, and he has no idea that there's an entire second terabyte that's completely hidden away at the namespace level. So, and then I can have two completely different operating systems. I can have Windows 10 on one, Windows 11 on the other one, Linux on one, Windows on another, whatever it is I need to do, and to be able to, switch back and forth between those. And so that's another capability that is incorporated. And that's, again, enabled by modifications to the firmware of the drive itself. Last slide, and then we'll get into some of the demo, is when you start adding additional hardware, it really opens up the amount of things that you can do with these drives. So if you add an accelerometer, you can do movement detection and response, for example. So an accelerometer can give you the ability to know if something is in motion, then it stops. If somebody has moved a device when they shouldn't have, maybe it's a desktop inside of a super secure facility and it should just never be moved, you can monitor for that. You can see that. Maybe it's, you left your hotel inside of the hotel safe and you're like, well, that should be secure. And then you come back and you're like, whoa, somebody touched my laptop. That's very strange and interesting. So, there's a lot of different scenarios. And then if you incorporate with capacitors on the drive and things like that, now you can start to have some automated responses. Maybe the response is just to log the information so you can know, and the adversary didn't know that you knew. But maybe it's like, no, somebody is accessing my laptop when it's in the safe. I want it to flip to the other side on dual mode, right? To the other namespace, or I want it to just, erase all my data or lock all my data. There's all sorts of reactions and actions you can do, and you can kind of imagine all the different things you can do with an accelerometer. Another one is detection response. So a lot of the PCs out there, your desktops and your laptops, they actually have this on the chassis itself, where if you were to take off the case or slide the case off the desktop, it actually triggers disconnect detections, and it saves and stores that inside the PC so that somebody can report on that and see that happened. So what you can do if you add that to storage devices, automatically have some response mechanisms if the drive is removed from the server, removed from the external media or the PC. And it could be all those same responses I mentioned with the movement detection response. It could be that it automatically crypto erases, and then as soon as it gets full power, completely erases the entire drive. It could be that it goes into dual mode. It could be, all sorts of different things that you would want it to do. But adding that detection and response with the capacitors for battery life really allows you to be able to go to that next level of adding that protection and really a self-defending storage device, which is, I think, really where the future is. And then if you add the microprocessor into it and you put in some of your own code that monitors and looks at the machine learning, or using machine learning looks at the different data access patterns, you can start coming up with some pretty creative responses as well. Also completely OS agnostic, that would allow you to be able to look for somebody trying to wipe the drive, clone the drive, boot up of a different USB stick, things like that. And then you can also use those secure access logs to be able to monitor for a ransomware attempt. So an encryption attempt that's not a known good encryption attempt, and to be able to have the drive itself automatically respond from within the storage itself. And again, completely agnostic to whatever else is going inside of the OS or the kernel or anywhere else. So that's it as far as slides are concerned. I didn't want to kill everybody with slides, and I wanted to have some time to be able to dig into the a demo itself. So let me go ahead and switch, and I will share a few different things really quickly, and so you can visualize what I just talked about. So I want to start with kind of the setup here. So this is a everyday computer here, as you can see, and I have all of OneDrive on here and a PC, and the C drive here is only part of the story. This PC is a full this storage has a PC, or this PC has storage, a 2 terabyte SSD in it. I have 1 terabyte of it that's completely hidden with that dual mode capability, so you'll never see it. And I also have only half of that 1 terabyte that is visible at this point. And so that C drive, if I were to go start looking and snooping around with WinHex here, I can start to see what's going on behind the scenes. And I'll go ahead and close these out for you guys, and you can see a fresh one. So as you can see there, it's a 1 terabyte drive. Only about half of that terabyte is associated to the C drive. And then I can click in here and start looking around, and I'll see, okay, there is another 400 plus gigabytes there in partition 4. But if I scroll down again, it's unreadable at the sector level. And that's what I would see if I were to take the drive out and look at it with microscopes, et cetera. And that unreadable state is really, the great value of what you're trying to get to be able to protect that data. For the user, all they have to do to unlock it is click here and be able to unlock it. And we at SciGen, at least, we use MFA factors to be able to get to unlock it. We have PIN, we have CAC and PIV and all these different things. But you would use like your PIN, and now you can access your drive. So now that 400 gigabytes is available, it's accessible, and you can go in there and access your data. So that's that fundamental of what I was talking about invisible data. We've incorporated that with what I talked about earlier, which is tamper-proof credentials. One of the things that I mentioned was this idea of having 2 different or a 2 terabyte drive that's split into 2. And so what you can see is, if I go into here to the BIOS screen and just show you this is what the BIOS looks like when you go look at that to see about that other 1 terabyte, is it there or not? And it will show, as you'll see here, it's just showing 1 terabyte at the BIOS level. And then I can go in there and I can use software to be able to switch back and forth between the 2 1 terabyte sides of it, the 2 dual mode sides. So those are a couple of the capabilities there. The other one that I would show you would be this idea of the keep alive heartbeat. So right now, if you look at this, I can go in here and access all of these files here. But if I go in here and disable the software using whatever tool that I have in mind to go do that, but disable the SciGen service, for example, in this case, the software will be able to be, it cannot, sorry, real quick. So the software has been terminated, the service is disabled. And if I go in there, and what is happening in the background is that the firmware of the drive is looking to see if the SciGen service is running and giving it its heartbeat, and it hasn't received it. It's been over 30 seconds. And when you try to go in there and try to access the files, it won't let you get access to those files because the drive itself is in that unreadable state again at the sector level. So you can see normally I'd be able to access that, but I can't access it because at the hex level again, or the sector level, it is unreadable. So that's that. So you've seen dual mode, you've seen the keep alive. Let me go ahead and get the SciGen service up and running again. And then we can start doing some other things here. So the erasure verification, I'll just show you kind of how that looks. I'm going to show you on a drive that plug in on a drive here and show you how that looks going into the software here. So going in here and looking at the drive itself, you can see here by clicking in advanced, you can go in here and do an erasure verification. And so on the erasure verification, you can see all of the blocks. You can see these gray ones are the firmware blocks. You can see the red blocks are the ones that still have data on them. And then all the green ones are the ones that actually got wiped. You'd be surprised, a lot of the software that you run, you think you can do a format command from Windows and it will wipe the data. It doesn't actually wipe all the data. And so this is really the creme de la creme, I would argue, way to be able to determine whether or not all the blocks on the drive have truly been wiped or not. So you have that. The command log is, I'll show you an actual command log that we ran here, and where I actually went in there and I did boot off of Tails OS, and I took this file off of the C drive, and then I was able to go in there and run the command log report, and you can see that it shows the file name. It sees whether or not the software that was running to protect that data was running or not. It shows you what drive letter, how many times it was accessed, and the date and timestamp. So there's quite a lot of benefit that you can imagine you can get out of that as well. So and I think that's about it. I just wanted to give you some of the highlights there of the core capabilities. Happy to answer any questions. If anybody has any questions, again, I'll just pop up that last slide here. If you guys want to be able to reach out to me, we'd love to share with you some more and discuss these ideas with you guys. So thank you very much. And with that, we'll see you on the chat window here at this show. Thanks.